Now discuss on tetravalence of carbon. As you know that the atomic number of carbon is
6.
the electronic configuration of carbon is 1s2, 2s2, 2p2. Carbon has two cells, first cell and second cell. In second cell there are two subcells, S and P. In S subcell carbon has 2 electrons. In P subcell carbon has 2 electrons. Total number of electrons in outer cell. Total number of electron in outer cell or valency cell is equal to 4. Hence, it requires other 4 electrons to complete its octet. To complete its octet. In ground state, 1s2, 2s2, 2p2, S subcell has 1 orbital, P subcell has 3 orbital. S has 2 electrons, P subcell has 2 electrons. According to valency bond theory, unpaired electrons are take part in bonding or to formation of covalent bond. In case of carbon, in ground state, there are 2 unpaired electrons, but it requires total 4 unpaired electrons. Hence, in excited state, 1s2, 2s1, 2p3. S has 1 subcell, 1 orbital, P subcell has 3 orbitals. So in this case, total number of unpaired electron is 4 and it can form 4 covalent bond with other atom or itself. With other atom means hydrogen, fluorine, carbon, so chlorine, bromine, iodine, but also can form bond with carbon. Types of bond formed by carbon. Carbon can form single bond, can also form double bond, can also form triple bond. Now, how can we determine the hybridization of a compound? Hybridization can be calculated by using the formula number of sigma bonds plus number of lone pairs. For example, if number of sigma bond is 2 and number of lone pair is 0, then hybridization is equal to 2 plus 0, which is equal to Sp. If number of sigma bond is 3 and lone pair is 0, then hybridization equal to sigma plus Lp 3 plus 0 equal to Sp2. If number of sigma bond is 2 and lone pair is 1, then hybridization equal to 2 plus 1 equal to 3 equal to Sp2. If sigma bond is 4 and lone pair is 0, then hybridization equal to 4 plus 0 Sp3. Now take some example. Number 1 example, CH4. In this compound, The central atom or carbon atom has number of sigma bonds equal to 4, lone pair is equal to 0 because carbon has 4 electrons in its outer shell. All these 4 electrons can form 4 covalent bonds. So it has no lone pair. অতএব hybridization equal to sigma plus lone pair is equal to sp3. So in this compound the hybridization of carbon is sp3. Take another compound CH3. In this compound we can determine hybridization for this carbon atom, also for this carbon atom. For this carbon atom sigma bond 4 and lone pair 0. Hybridization equal to 4 equal to sp3. Similarly for this carbon atom also sp3 hybridization. Take another example. CH2 double bond CH2. Double bond exists between carbon and carbon. We can determine hybridization for these 2 carbon atoms. This carbon atom can form a double bond and also 2 single bonds. In a double bond, one is sigma, another is pi. In single bond, all are sigma. So total number of sigma bond for this carbon atom is 3. Number of lone pair 0. So the hybridization sp2. Similarly for this carbon atom has also hybridization sp2. Take another example. CH triple bond CH. In triple bond one is sigma, other 2 are pi bonds. So when we calculate hybridization for this carbon atom, one is sigma, in triple bond also exists a sigma bond. So total number of sigma bond is 2, lone pair is 0. অতএব hybridization is sp. So we conclude that when only single bond is present between carbon and carbon, the hybridization is sp3. When double bond is present between carbon and carbon, the hybridization is sp2. When triple bond is present, the hybridization is sp. Take another example. For example, NH3. As we know that nitrogen has 5 electrons in its valency shell. In this compound, 3 hydrogen atoms can form bond with nitrogen. The number of sigma bond is 3. Lone pair is 1. অতএব hybridization equal to sigma plus lone pair, which is equal to sp3. Take another example, water. Oxygen has 6 electrons in its valency shell. Number of sigma bond is 2. Number of lone pair also 2. So hybridization also sp3.